Hi everyone. Today we're going to study L'Hopital's rule for infinity over infinity case. We can use L'Hopital's rule to evaluate limits of quotient f of x over g of x, in which f of x approaches positive or negative infinity and g of x approaches positive or negative infinity. Limits of this form are classified as indeterminate form of type infinity over infinity. Note that we are not dividing infinity by infinity. Since infinity is not a real number, that is impossible. Rather, infinity over infinity is used to represent a quotient of limits, each of which is infinity or negative infinity. Let us have the formal definition of L'Hopital's rule of this case. Suppose f and g are differentiable functions over an open interval containing a, except possibly at a. Suppose the limit of f of x as x approaches a equals positive infinity or negative infinity, and the limit of g of x as x approaches a equals positive infinity or negative infinity. Then the limit of f of x over g of x as x approaches a equals the limit of f prime of x over g prime of x as x approaches infinity. This formula here is what we call now the L'Hopital's rule. Assuming the limit on the right exists or is positive infinity or negative infinity. This result also holds if the limit is infinite, if a equals infinity or negative infinity, or the limit is one-sided. Let us see these examples with two sample problems here. Instruction is evaluate each of the following limits by applying L'Hopital's rule. Problem A, the limit of 3x plus 5 over 2x plus 1 as x approaches infinity. Analyzing the numerator, since the limit of this 3x plus 5 as x approaches infinity equals positive infinity, and the limit of the denominator 2x plus 1 as x approaches infinity equals positive infinity. Thus, this is infinity over infinity type. Therefore, we can apply L'Hopital's rule. Let us copy this same problem down here, and by L'Hopital's rule, we will take the limit of derivative of numerator over derivative of denominator as x approaches infinity. Derivative of numerator is 3, while derivative of denominator is 2. Evaluating this limit now, we have this limit of the constant 3 over 2 as x approaches infinity is 3 over 2. This is the final answer. We'll just copy this opposite problem A. Let us solve problem B. The limit of ln x over cotangent x as x approaches 0 from the right. So this is a right-handed limit. Let us analyze the limit of the numerator. So we have the limit of ln x as x approaches 0 from the right equals negative infinity, while the limit of the denominator, cotangent x, as x approaches 0 from the right equals positive infinity. It means this is infinity over infinity type. Therefore, we can apply L'Hopital's rule. Let us copy this problem here, and by L'Hopital's rule, we will take the derivative of numerator over derivative of denominator. So derivative of ln x is 1 over x, while derivative of cotangent x is negative cosecant square x. When we simplify this complex fraction, we will get 1 over negative x cosecant square x. We know that the reciprocal of this cosecant square x is 1 over sine square x. If we substitute that formula in here, and when we simplify the complex fraction, it becomes sine square x on top over negative x as denominator. Now, let us evaluate the limit of sine square x over negative x. And this will give us 0 over 0. It means this is another indeterminate form. In this case, we will apply L'Hopital's rule again. So we have now the limit of the derivative of sine square x over the derivative of negative x as x approaches 0 from the right. Derivative of sine square x will give 2 sine x cosine x over derivative of negative x is negative 1. When we evaluate this limit, we will get 2 times sine x becomes 0, cosine x becomes 1 over the constant negative 1. And all this expression will give us 0. This is now the final answer. Let us copy this answer opposite problem B. There is an important reminder here. To apply L'Hopital's rule to a quotient f of x over g of x, it is essential that the limit of f of x over g of x be of the form 0 over 0 or infinity over infinity. I hope you learned something from this video. See you again next time.